Okay, let's do a torque and moment of inertia gizmo. So we're just going to search for torque, and if we just put in tor, the first one comes up, and we're going to launch the gizmo. As always, you want to go to the pull-down menu here, so you can click and get the vocabulary sheet, so you can see the words that are appropriate for this gizmo, and then we'll click on the student exploration sheet. Again, this is the instructions that show you how to go through the gizmo, and it also has places for you to answer questions and to record any of your data. So when we go back to this gizmo over here, this one's very straightforward, and it's one that we would have done in class as well. We basically have a bar that's balanced over here, and it's a uniform bar, which means the center of mass is right in the middle. And then all we do is we hit release, and then we want to see if we can balance the bar. Clearly this one is not, and then we go back and hit reset. So what can you do? You can change the position of these different masses that are on here. You can also change the amount of kilograms for each of these masses. We can also give the mass, the bar mass too, if we slide this back and forth. And we can also increase the number of objects that are on this bar. And ideally what happens is if we show the moment of inertia, and if we click this, it'll say it'll be displayed when it's released. It'll show the moment of inertia of this bar. And then if there is a torque that's applied to either the right side or the left side, then it will cause a rotation, right? If there's a torque that's bigger on one side than the other side. If the torque is balanced, then the net torque will be 0, and it should just hang out right there. So we can show the moment of inertia and we can also show the torque. And when we release this, you can see we actually get numbers. So this has a negative torque, right? So negative torque means that it will rotate clockwise. Positive would be counterclockwise. And then over here, it gives the number to the moment of inertia. It doesn't give the equation for it, but it gives the actual number to it. And then of course you can also use the ruler so you can see exactly how far apart you're putting these masses from your axis of rotation, which is right here. We can also move the fulcrum back and forth as well. So we can do all kinds of things to change the moment of inertia and the torque to see if we can get this bar to stay in equilibrium. And that's the gist of this gizmo. So have fun with it. It's very straightforward. And let me know if you have any questions.